Okay, we're moving on to chapter 5. So today we're covering 5.1, which is solving systems of linear equations by graphing. So a system of linear equations is a set of two or more equations with the same variable. In other words, I'm giving you two equations at once, and we want to know where is it a solution for both of them at the same time. So that's what the solution is. It's always going to be an ordered pair. That's a solution for both of the equations. So if an ordered pair works for one equation and it works for the other, then it's going to be a solution overall. Let's see. So, steps. Step 1 is you're going to graph each equation in the same coordinate plane. Step 2 is you're going to estimate where they intersect. And then step 3 is actually going to plug that point back in. Check it. Does it actually work? Okay, so we're going to actually learn 3 ways to solve a system of linear equations. This is just the first way, solving by graphing. And then we'll learn 2 additional ways as well in the upcoming notes. All right, so if it says to tell whether the ordered pair is a solution of the system, all it's asking is, it's saying plug this coordinate point of 3, 1 into x and y and see if it works. It has to work on both of your equations. Otherwise, then the answer is no, it's not a solution. So if I take the point 3, 1 and I plug in a 3 for my x and a 1 for my y, is 3 plus 1 equal to 4? Yep, so it works for that one. But now we need to try it with the second one. So I'll have 2 times 3 minus 1 equal to 3. Let's see if that works. So 2 times 3 is 6. 6 minus 1 is 5. It is not equal to 3. So that means that no, it is not a solution. It has to work for both. Otherwise, it doesn't work at all. All right, so we can try number 2 and 3 and check in and see how you did. Okay, so I'm going to plug in a 1 and a 3. 1 minus 3 is negative 2, so it checks out. If I plug in a 1 for my x and a 3 for my y, 2 times 1 is 2, plus 3 is 5. Checks out, so yes, it is a solution. On number 3, I'll plug in a 0 for my y and a 2 for my x. 2 minus 2 is in fact 0, so that one checks out. If I plug in a 0 for my y and a 2 for my x on my second equation, negative 3 times 2 is negative 6. Negative 6 plus 6 is 0. So yes, that coordinate point is a solution. All right, so now it says to use the graphs to solve. All that means is we want to know where do those two lines intersect. So we're wanting to identify this coordinate point, and that is our solution. It's the only place where a point is on both of your lines. So this coordinate point would be, I won't go to the right 2 and down 2, so it'd be 2, negative 2. On number 8, I'd go left 1 and down 3, so that'd be negative 1, negative 3. And then number 9, I'd go right 4 and up 2, so that would be the coordinate point 4, 2. So that's the solution. That's what we're looking for. We want to know where those two lines intersect. So if the graph's given to you, it should be very, very quick. If the graph's not given to you, all you have to do is graph them, and then you're looking for the exact same thing. You're looking for where do they intersect. So go ahead and graph number 10, and then tell me the point where they intersect. Okay, so number 10, the first equation has a y-intercept of 3, so that's the first point I'm going to put, and a slope of negative 1, which means up 1 to left 1, or down 1, right 1. So there's my first point. I'm going to connect it using a straight line, and then I'll graph my second one. My second one has a y-intercept of 5, and a slope of positive 1, so up 1, right 1, or down 1, left 1. And then again, connecting those points. And you can see the place that they intersect is right here. That is the coordinate point negative 1, 4. So that's my solution. All right, try number 11 and then check and see how you did. All right, so the top equation has a y-intercept of 2 and a slope of 1/2, which means up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. And again, connect it, straight line. And the second one has a y-intercept of 4 and a slope of negative 1/2. So that means up 1, left 2, up 1, left 2, or down 1, right 2. And when I connect them, I can see that my coordinate point where they intersect is right there, and that is the coordinate point 2, 3. The last one, the top equation is not in slope-intercept form, so let's put it in slope-intercept form. So I want to subtract the 3x over on both sides, which will leave me with a negative 2y is equal to negative 3x plus 6. When I divide by negative 2, I'm left with y is equal to 3 over 2x minus 3. So that means my y-intercept is down here at negative 3, And a slope of 3/2 means I go up 1, 2, 3, and over 2. Up 1, 2, 3, over 2. And connect them. When I have the equation y equals -3, that's a horizontal line where y is -3. So that means I have a horizontal line where y is -3, which means they intersect at the coordinate point 0, -3. So again, if I'm asking you to solve a system of equations by graphing, you graph them and tell me the point where they intersect. All right, it's the same thing, even if they give you a word problem. You're still writing the equations, graphing them, and finding where they intersect. So you can try number 16 if you'd like, see how you're doing at the word problems. Okay, so it says the test has 20 questions worth 100 points. They have true-false questions that are worth 4 points and multiple choice questions that are worth 8 points. Total, there are, 20 questions. Okay, so multiple choice plus our true-false plus our multiple choice equals our 20 total questions. And then it says they're worth 100 points. So each of my X questions are worth 4 points. Each of my Y questions are worth 8 points. And total, there's 100 points on the test. Okay, so I've got my two equations, and now I can get them in slope-intercept form and graph them. So if I subtract an X over, I get Y is equal to -1X plus 20. And if I subtract my 4x over, I get 8y is equal to -4x plus 100. If I divide by 8, then I get y is equal to -1/2 x plus about 12.5. So if I am graphing them, the first one has a y-intercept at 20 and a slope of -1, which means I'm going down 1 over 1. Down 1 over 1. So let's take a look at my scale. They're going down by 2s and over by 2. So I can just follow it down. And that is going to be my first graph. So I can connect those points. My second one has a y-intercept of 12.5. So that's going to be about here. Let's see. Oh. So 12.5 is about right here. And a slope of -1/2 means that I will go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So it's going to cross somewhere right in this area there. Okay, so my solution is going to be somewhere in that point right there, which is going to be, looking at my graph, it's hard to tell exactly, but we are able to get an approximate. And if we were to graph it super accurately, we would see that there are 15 true false and 5 multiple choice. Take a second.